Hi guys, welcome to our lesson. So today we're going to be looking at some special quadrilaterals. This is all under geometry, which is what we are trying to get across. But now we're going to look at what are the properties of these special quadrilaterals that we focus on. There are a lot of quadrilaterals, but we're going to choose a few that we call them special because of the relationships that they have and how the relationships overlap with other shapes in that particular list. So let's look at it together. So what we're going to be looking at will be quadrilaterals. You know, it's a shape with four sides. Going to look at a parallelogram, a rectangle, a rhombus, and a square. And then at a later stage, you'll understand why all these arrows are there and what they really mean. But for now, let's look at the types of quadrilaterals. But it is very important for you to note that these are not the only ones, right? So these are not the only ones, please. There are other quadrilaterals, but we're only looking at these ones because there's some interesting facts about them that we can try and overlap across. Now, what are the properties of these quadrilaterals is what we're going to try and focus on. But first, let's look at a parallelogram. Now, with a parallelogram, the shape of a parallelogram looks something like this, right? But then, if I did not give you the diagram, how would you then say, okay, this diagram is a parallelogram? Rather, if I did not give you the word parallelogram in the statement I meant, right? So if my statement does not say the following shape is a parallelogram, how will you then claim that this shape that I just drew here is a parallelogram? Because I must caution you here. In geometry, guys, monkey see, monkey do does not apply. Meaning, because it looks like something, it does not make it that something, right? So it might look like a parallelogram, but it might not be one. It might look like a square, but it might not be one because of something very tiny there. So you always need to find what are the properties, what are the reasons of it being that at that time, if you want to claim that it is that, right? So with this one, if we have a parallelogram, what we know is that both pairs of opposite sides are parallel, right? Both pairs. Now, I used different colors here to show you this, right? So this is blue, and this is white and white. At times, you will see that they use two arrows like this and then one arrow there to show that not all lines are parallel, right? So that's why I used different colors. So these two would be parallel and these two would be parallel. So please note that, right? So at times they can use that. So maybe to draw a shape for you to see what I'm talking about. Our shape will look like that. And then the other thing that we know is both of these opposite sides are parallel and also equal to each other. And as you can see, I'm using different colors there, but let's just do this so that it's not one lines for all of them and then it ends up confusing you. So this is what we mean. That's the second important thing. The other important thing is that both pairs of opposite angles are equal. So these are opposite angles, they are going to be equal, and those are opposite angles, they are also going to be equal to each other. And then the diagonals bisect each other, meaning this diagonal here is cut into two equal parts by the orange diagonal, while it is also cutting the orange diagonal into two equal parts. So you can see that will be equal to that, and this will be equal to this, right? So I'm just trying to show you why I'm having two lines, just that they are different colors to mean different things. Now, what do we know about this? With a parallelogram, our properties will be opposite sides are parallel, number one, opposite sides are equal, opposite angles are equal, and lastly, the diagonals bisect each other. That's what makes a parallelogram. Now, What about a rectangle, right? If we have a rectangle, how can I then say this is a rectangle without being told that it is a rectangle? So in simple terms, what are the properties of a rectangle? Which is therefore, if we have a rectangle, we know that both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, and lastly, the diagonals also bisect each other, right? But the very interesting thing about this thing is all of these properties I've listed here, they are all properties of a parallelogram. So what does that tell us? It tells us that a rectangle has all the properties of a parallelogram being true, right? But what then makes it different from a parallelogram is that the diagonals don't only bisect each other, they bisect each other while they are equal. So if I say these diagonals are equal and they bisect, it will make that to be equal to that, which will make that to be equal to that. But because they were equal, all of them will now be equal to each other. So in simple terms, this point is what cuts the two diagonals into 4 equal segments. And then also what we know is all angles are equal and equal to 90 degrees. So if this is 90 and that is 90, they are opposite. It means they are equal. That's a property of a parallelogram. Remember we said they are true. Also, if that is 90 and that is 90, they're going to also be equal to each other. Why? Because they are both 90 and they will be opposite and equal, which still goes back to proving that it is one of the properties of a parallelogram that we are talking about. Now, let's try and link all of this and see why now I have all these errors of mine. So I want you to please pay attention to the colors that I have here, right? There are a lot I know, but I will make sense of them just now. So we start with our parallelogram with the purple arrow there to say a parallelogram has opposite sides are parallel, opposite sides are equal, opposite angles are equal, diagonals bisect each other. But the interesting thing that we found out was that even a rectangle has the very same properties. So what does that mean? It means that a parallelogram, or rather a rectangle, is a parallelogram, right? But it is a special kind of a parallelogram. We start with a parallelogram. Not that a parallelogram is a rectangle. That does not exist, right? A rectangle is a parallelogram, but what makes it a rectangle and not a parallelogram will be the 90-degree angles that we introduce there. Hence, you can see that it goes up there again to say the angles are 90 and the diagonals are equal to each other. So those are the interesting properties of what a parallelogram is with respect to what a rectangle is, right? When we come back from the ad break, guys, because I know this is a lot, we're going to now compare what a rhombus is with respect to what a square is and see if there are any similarities there, or even if to check if there also are similarities with these first two quadrilaterals, a parallelogram and a rectangle that we've just done. But for now, please stay tuned. I'll be back just now. Stretch a bit and come back after the ad break. Hi guys, welcome back from the ad break. I hope you are a bit refreshed. Now we're gonna compare a rhombus with a square and with the other two shapes. Now, guys, if you look at what we did with the first two shapes, right, which is a parallelogram and a rectangle, we looked at what are the similarities, right? Because the parallelogram is like the umbrella, I promise you, with these special kinds of quadrilaterals that we're going to look at. But now, we found that there are similarities between it and a rectangle. But what that therefore means is we will then need, the next layer will be to find what makes the rectangle to be different from a parallelogram, right? So that I can classify them, because then what will be the need for me to say parallelogram, rectangle, rhombus, and a square if I can just call all of them parallelograms? It is because of that one or two or three different properties between these two particular shapes. And then also because of the similarities, we know we can classify them all under the fact that they are a parallelogram. But let's just try and investigate whether a rhombus can also be considered as a parallelogram, and a square can it also be considered as a parallelogram. So now, what are the properties of a rhombus? And that's the first question that we're going to ask ourselves, right? And we're going to explore that. Then from there, the second question that we're going to ask ourselves is, based on those properties, can I then classify it as a parallelogram, classify it as a rectangle, or even classify it as a square? And why will I be able to do that? Based on what I would have tried to answer with those properties there. Now, if we have a rhombus, what we know about a rhombus is both pairs of opposite sides are parallel. That's the very first thing, right? So my blue and my blue, so those will be parallel and opposite, and that one there will be parallel and opposite. Also, we know that those pairs that we have, they are also equal to each other, making this to be equals to that, and making this to be equals to that there. Then the other interesting thing about this is opposite angles are equal. Guys, hang on. Are we not talking about properties of a parallelogram here? Because it's like I'm still repeating properties of a parallelogram, right? That's the interesting thing that I want you to please see. Also, the diagonals bisect each other. So as a result, the golden conclusion is that all of these properties are of a parallelogram. But then, why do we call it a rhombus and not a parallelogram? And that's because of the following reasons that we're going to state. So to answer the first question, the properties, we've stated them, but they are incomplete because we still need to say, why is it now a rhombus and not a parallelogram, right? Because I gave it or rather mathematicians gave it a different name from a parallelogram. But we know that it is also a parallelogram, right? So it is under a parallelogram, but why did we call it a rhombus? Now, those are the other properties that we need to look at that made us to call it a rhombus. The very first one is that all sides are equal. So this is a very interesting fact, right? Now, with this, I want you to think about something, right? When we started looking at shapes at the very early grades of mathematics, you know, a square is something that we use to see. It's a cube, right? A cube is made up of a lot of squares and all of that. And what is a square? All the sides are equal, right? So now, we just said all the properties, all the sides of a rhombus are also equal. So do you now see there's now an overlap that goes into a square, which we're going to try and talk about later on. In simple terms, this is what I want you to see. A rhombus will now be, if I straighten it, what will it give me? I want you to think about that while we are trying to talk about this, right? I have a rhombus. It is more or less like, you know, a bit tired. You know, when a person is tired, if they stand up right, which is you straightening it, what shape will it be? Think about that while we are trying to go through this. Now, another property is that the diagonals bisect each other now at right angles. So they don't just bisect each other, but they bisect each other, making 90-degree angles while they are bisecting each other there. So that's one very special property that we have there. And then the diagonals bisect the angles. What angles are these? The diagonal will bisect the angles on either side of the diagonal, making this angle to be equal to that angle, this angle to be equal to angle. But hang on, I was told that if I was to call this A, call that B, call this C, call this D, I was told that A is equals to C. So what does that mean? It means A1 and A2 are equal, together with C1 and C2 are also equal. But does this not make 4 equal angles? It does, because this will be X, 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 X. You see, if I was to try and talk about it in terms of X. Now, with all that being said, it means that we can now try and look at a rhombus to be classified as one. It has opposite sides that are parallel. It has opposite sides that are equal. It has opposite angles that are equal. It also has diagonals that bisect each other. But what was very interesting about it was that all the sides were now equal, and the diagonals were bisecting each other at 90 degrees. So that's why it is overlapping, and not only do we consider it as a parallelogram, we make it a specific parallelogram. Now, what are the properties of a square? Also, is a square considered to be a parallelogram, a rectangle, or even a rhombus for that matter? Now, if we have a square, what we know is that both pairs of opposite sides are parallel. So I will have this to be parallel to that, and then I will have this to be parallel to that. Then both of these pairs are also equal to each other. Hence, this will be equals to that, and then this here will be equals to that. Both of the opposite angles in terms of the pairs are also equal, making this here to be equals to that there, and making this to be equal to that there, right? So you can see, I am busy mentioning this, but I'm now thinking, is this not even the same properties of a parallelogram that I'm supposed to know? It might be. So let's see what last property we have. The diagonals bisect each other. No, hang on, man. These are just the properties of a parallelogram. But why do we then call this a square? Let's think about that. Firstly, we know that all these properties that we've spoken about, they make it to also be considered as a parallelogram. So I will start by saying all the properties of a parallelogram hold, but now the most interesting thing here is that the diagonals are equal. Also, the angles are equal, and they are equal to 90 degrees. What does that do? It now introduces the fact that this is a special type of a parallelogram. It is a parallelogram that is a rectangle. But why? So what do we then say? Is a square a parallelogram, a rectangle, or a rhombus? We can actually say a square is a rectangle. Why? Because now that it does have the properties of a parallelogram, when we add a few other properties, it now overlaps to being a rectangle. So it makes it now a rectangle, other than it being a parallelogram. So if we have a square, it means that all the properties of a parallelogram hold, all the properties of a rectangle hold. But now the interesting thing that we need to add now also is, if both the properties of a parallelogram and a rectangle hold, what must I call it now? Because, all right, it's a parallelogram, but there's some properties that are short there. I must add them. It gives me a rectangle. Now I'm thinking, all right, what are the other properties? The other properties are that all sides are equal. Ching ching, now we are thinking rhombus. All right, the diagonals bisected right angles. Rhombus again. the diagonals bisect the angles. This is a rhombus. So it means all the properties of a rhombus also do what? Hold in this particular shape. So now, this is a very interesting type of a quadrilateral, because all three quadrilaterals that we've mentioned, they hold in a square. So a square can be a parallelogram, can be a rectangle, can also be a rhombus. But why do we call it a square then? And I'm conflicted now. What do I call it between these three things? Because now I can label it as three things. Let's continue and see exactly. Now, all properties of a parallelogram are true. That's nice. Rectangle, true. Okay. Rhombus, true. So as a result, that makes a square to now overlap in all of them. You see, firstly, a square can be a parallelogram because it has opposite sides parallel, opposite sides equal, opposite angles equal, and the diagonals bisect each other. But in that, I also know that the sides are equal. I also know that the diagonals bisect at 90 degrees. Lastly, I also know that these angles that are equal, they are also 90 degrees. Also, the diagonals are also equal. So, hey, this means a square is now protruding, or rather overlapping, in all the properties that we have here. So as a result, what do we classify a square is? We can classify a square as a rectangle, as a rhombus, or as a parallelogram, based on the fact that it overlaps in all of them. But we call it a square. Why? Because it's special. It has all of the above properties to be true. And that's how you classify these four quadrilaterals of mine. And I chose them because they have so much in common with one another, which makes them very, very special quadrilaterals. And that's how you then look at which quadrilateral is which and how do you classify them based on the differences in those particular quadrilaterals. All right, guys, we've come to the end of what we need to do for now, but I want us to take a quick ad break, because when we come back, we're going to look at some more problems and some more information that has to do with these quadrilaterals. Please stay tuned. I'll be back just now. Hi guys, welcome back. So we are still looking at the special quadrilaterals, or rather we are still looking at quadrilaterals and what they are all about, right? But now we're going to be looking at answering some questions now of these particular quadrilaterals that we are talking about, to try and now apply these properties that we've mentioned in trying to use the deductive reasoning and find certain relationships and certain angles in these particular quadrilaterals. So let's just look at the very first question that we have. But before that, we must look at some terminology that we are going to use when talking about all these shapes. So I have the terminology produced. Now, the most interesting thing about this word is, the very first time I saw it when I was doing maths as well, was what exactly does produced mean? Does produced mean that this is like in a supermarket where we're producing something, or a manufacturer rather? No, but in mathematics, when we are saying something is produced, we mean that a line is extended. Right? So a line is extended, because to produce, we only produce lines, guys. We don't produce anything else in maths. We produce lines, right? So if I use the term AB is produced to C, it means that this was AB, and then I extended this to give me C. And why am I saying it is produced? It is because it is extended such that it is on the same plane plus collinear, right? Collinear. Collinear would simply mean that they all on the same straight line. So this is the same plane, which is AB, and it continues to be the same line with BC, right? Not that from AB I must go to C, which will be somewhere there. No, this is the wrong one, and this will be the correct way of looking at what produced means. Let's see if I can apply this somewhere. But before I do that, I want to also point out one more thing here is when we introduce produced, then you can consider, right? You can now consider an exterior angles of shapes. I will just say shapes because not only a triangle or not only a quadrilateral has an exterior angle. It can be a hexagon and a pentagon, which we'll look at the later stage as some other shapes that we look at in geometry. Now they said, or rather the question says side FI of parallelogram EGIF is produced. Hey, they're introducing this nice thing of mine. This is produced to H so that EF is equals to GH. But firstly, what does this tell me? They are telling me that FI is extended, right? So meaning, although FI is the one that will be said is to be parallel to FEG, because IH is still part of FI, we will then say all of this line, the whole line, is actually parallel to, I wanted to erase this part. It means that the whole line is now parallel to EG, right? Not just this portion, no. The whole portion is parallel to EG. So I hope that clarifies what I mean there. Now we need to calculate the sizes of G1 and F if I have that as 52 degrees. But before that, let me show you. We know that this is a parallelogram, right? If we do know that, it means this angle will be equal to that angle. This angle will also be equal to this angle, right? And then we are told that this is 52 degrees. So what do I now want to do? I want to find what G1 is, number one, and also to find what F is. But before finding G1, I must tell what this is, right? And if I know what that is, then I can try and find what G1 is. And based on that, since I know this line is parallel to that line, I can use these angles here to claim that they are co-interior angles, and then because EF is parallel to GI. So that's my thinking here, but this is just still a brainstorm, right? To do this, we first look at the properties of a parallelogram, which is what I've just done right now. The sides are parallel, they are equal, angles are equal, and diagonals bisect each other, right? Bisect each other. So making them to have equal sides. So this will be equal to that, and this will be equal to that, right? But now, how do I use all of this to find what they want me to find? I remember I showed you how to talk about those properties, right? But now, why is this angle, right, equal to that angle and also equal to that angle? We need to think about that, right? But we firstly need to go back and look at what were we told. We were told that, if you go back to our statement, EF is equals to GH. So there is GH there, which is equals to EF, which therefore makes GH to also be equals to GI, because GI and EF are equal, which is a parallelogram. You see, so that's how they overlap with one another, and that's how we're going to use it. So to write this down using the deductive reasoning will be, I will start by saying, I know that angle G2 is equals to angle I1, and the reason for this will be alternate angles, and that was because I know that EF is parallel to, or EG rather, not EF, sorry, EG, because we are not yet talking about EF. EG is parallel to FH, right? And based on that, I also know that the angle H1, I1 I mean, will be equals to angle H, right? So I will say I1 is equals to H. But I'm thinking before that, I need to have told the person who's marking why I'm going to say these are angles opposite equal sides. So we first say EF is equals to GH, and this was given to us, right? But we know that EF is equals to GI, which will be equals to GH, and this will be because of prop of a PAM, which I will just say PAM, that's short for parallelogram. So as a result, I will then say that I1 is equals to H. I1 is equals to H, and that is because of the fact that this is angles opposite equal sides, right? Then lastly, I will then say, I know that G1 will be equals to 180 degrees minus 52 degrees minus 52 degrees. And this will be sum of angles in a triangle, and then you find what that value is, right? So if you minus 52, this will be 128. You minus 52 again, it will be 76, right? So this will be 76 degrees. And that will be G1. So I have found that. Now I need to talk about F. What is F? I know that F is equals to I1. Why? Because of corresponding angles. So I will just say this is equals to F is equals to I1, and this is because not equal bracket to talk about the reason, right? And this is because corresponding angles. And remember, with the corresponding angles, you must indicate EF is parallel to GI, right? I know that. And then since I know what I1 is, which was 52 degrees, I will then say F is also equals to 52 degrees, which was what part of this working out that I have here. So that's how you then try to use the deductive reasoning based on the properties of these shapes to try and find some answers with the values that we give you. And I know that this might be a very complex thing to think about, but I promise you, if you indicate the properties of that shape on the diagram based on what you are told the shape is, then everything else will just fall into place. Because if you go straight to trying to answer the question without understanding the relevance of the statement on the diagram, then it will be difficult for you. So make sure You interpret the statement, put it on the diagram, and then answer the questions from there. I hope you are having so much fun, guys. But for now, I want us to take a quick ad break. When we come back, we'll answer another question that has to do with finding some values based on the properties of these shapes. Please stay tuned. I'll be back just now. Hi guys, welcome back. So now we are in our last segment for the show. We are going to look at more questions now of applying all these properties that we're talking about, right? But for now, let's just jump right into it, because we've really been exhausting all the properties and trying to say how do they relate with what we are trying to talk about. So let's just look at the very first question about a rectangle. So it says here, if ABDC, right, is a rectangle. Now look at this, ABDC, not ABCD, right? Because it is moving in an anti-clockwise direction. So please just note that. If this is a rectangle, the diagonals and that intersect at K, and K1 is 120. Then I want to find what is B1. So firstly, we go back and look at what are the properties of this particular rectangle. The properties of a rectangle is that all the properties of a parallelogram are very true. The additional properties are that the diagonals are equal and the angles are equal and equal to 90 degrees. So what that simply means is this here becomes an isosceles triangle. That there becomes an isosceles triangle, making this angle to be equal to that, making this angle to be equal to that one there. So that's what we're simply talking about. Now, so what do I know? I know that this is supposed to be equals to that, which will be equals to that, which will be equals to that. So as a result, all four angles are going to be equal. I know that. And then I also know that since these two lines are equal, it makes it an isosceles triangle. Now to find B1, I will start first by saying what is K2, right? I can look at K2, or I can just go straight to finding what B1 is. Why? Because I will say K2, or K1, not K2, because we're saying we're starting with the method of finding K1. So K1 is equals to A2 plus B1, right? And what do we know about this? We know that these two angles are equal to each other, right? And but what we know is that A2 is equals to B1, and this will be because its angles opposite equal sides, right? And then the last thing, by the way, is I forgot to just write the reason for us here, which is the exterior angle of a triangle, right? And then what do I know? I will therefore say K1 is equals to 2B1. Why 2B1? Because I'm just only interested in finding B1. But K1, we know it was 120 degrees is equals to 2B1. So as a result, my B1 will therefore be equals to 60 degrees, right? And that's how I can solve this. The other way that I said would be to find K2. If we were to find K2, I will use K2 is equals to 180 degrees minus 120. And this will be adjacent angles on a straight line, adjacent angles on a straight line, right? And then I can then use sum of angles in a triangle, this triangle here, in order to find what B1 is. So you can see there's many ways to solve this, not only what I have done on the board. Now, PNOM is a rhombus with PMO being equal to 56 degrees. The diagonals PO and MN intersect at Q, and we need to calculate the size of O1. So where's my O1? I'm trying to find that angle there, right? So we first we first need to remember the properties of a rhombus. What we know is a parallelogram is part of all the properties that are there, and then additionally sides are equal, diagonals bisect at 90, diagonals bisect the angles. So as a result, my diagram will look like this, right? Where I have all these additional extra additions that I was given. So just remember, they told us that PMO is the 56 degrees. So this whole angle is 56. It therefore makes this to be half of 56 and this to be half of 56. So this will be 28 degrees and that will be 28 degrees, right? If those are 28, it means this is 28 and this is 28, you see. So now I'm getting somewhere, and based on that, I can then find what that angle is, or I can just find what that angle is using this as a 90 degrees. So here, there are a lot of things that I already know just because this is a rhombus. So what do you want to do? We want to find what O1 is, right? So to find what O1 is, I will start first by saying M2 is equals to 28 degrees. And my reason for this will be properties of a rhombus, right? Properties of a rhombus. And then from there, I know that based on that, I will say that Q4 is equals to 90 degrees. And my reason for this will be diagonals, right? Diagonals bisect at 90 degrees. Bisect at 90 degrees. And then from there, I will then say that my O1 will be equals to 90 degrees minus 28 degrees, and this will be sum of angles in a triangle. So as a result, this will be, I must minus 28 from there, so this will be 62 degrees, all right? Just verify for me there. I'm just using my head. It's quite big, so it does get things correct. So please just verify, but it is supposed to be 62 degrees there. So that's how we can find O1. Now with this one, we know that RUTS is a square, right? Now, it being a square, we're going to need to think about the properties of a square because we are going to use them somewhere here. V is a point on RS such that RVU is 64, I mean. 64 degrees, I can see there, I've shown you. And then lastly, if UV intersects RT at W, so these are now straight lines making this angle and that angle to be equal because they are vertically opposite angles. Now I want you to find what is W3. But first, remember, go back to the properties of a square and then apply that on the sketch. So we know all sides are parallel, the opposite sides are parallel rather. Sorry, all sides are equal to each other. All angles are equal to 90 degrees. The diagonals bisect the angles of a square. So if the diagonals bisect the angles, it makes this 45, it makes this 45, because in total, this is supposed to be 90 degrees. You see, this is 45, that is 45. So all of these angles will be 45, 45, 45, 45, just because of the fact that the diagonals bisect those angles. And then also the diagonals bisect each other at 90 degrees. So I have a lot of 90-degree angles there. Lastly, the diagonals are equal to each other, which introduces the concept of us looking at isosceles triangles. But now, UV is not a diagonal, right? But I know that this is 45 degrees. So what will I then use? I will then try and think about this angle here in order to try and find what W3 is, because I will just use the sum of angles in a triangle with that one, right? And then I will know what W3 is. So to do that, I will then say W1 is equals to 180 degrees minus 45 degrees minus 64 degrees. And this will be equals to, the reason for this will be sum of angles in a triangle, right? Sum of angles in a triangle. So as a result, minus 45, that's 135, minus 64, that's going to be 71. Right, I think that is going to be 71 degrees. Please just verify for me. And then lastly, what do I know? I know that W3, right? W3 is equals to W1, and this will be vertically opposite angles, right? Vertically opposite angles. And therefore, W3 will be equals to 71 degrees. And that's what I will then have from there. So please make sure you are clear on that. Now, with all of these nice properties of mine, you can see how we can now play around with these properties based on the fact that they are overlapping one another. But guys, really, you have to agree that maths is a very nice subject, as long as you know exactly where you need to go. But for now, I need to love and leave you because we have come to the end of our session. Until next time, but remember, mathematics is food for the soul.